So I hear you want to learn about the binomial distribution. Well, you've come to the right place. Welcome, my friends, to 6-Minute Statistics, where we take one topic at a time and talk about it in simple and straightforward language. Today's topic, we're going to introduce binomial distributions. Come on!
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Hello again, Mark here from 6-Minute Statistics, and I'm super happy that you found my channel. I hope to answer the questions you have about statistical topics. If I am providing you some assistance, go ahead and hit that like button and think about becoming a subscriber. That way, you'll get notified when new videos get posted, and it'll help me reach my subscriber goals for the year. And thanks. Let me start this video with a scenario that plays out every year, especially during the winter time. I have two good friends who are firefighters, and there's nothing so sad to a firefighter as when they roll up on scene and they find somebody's been injured, or even worse yet, has died in a fire. Especially when we know they can be preventable. Fires sometimes can't be preventable, but the injuries and deaths that result from them can. And it all starts with your smoke detector. Did you know that 3 out of every 5 deaths in a fire can be attributed to a home that doesn't have a working smoke detector? That's terrible, especially when they're so easy to have and so easy to get working. My firefighter friends tell me that only 80% of all homes have operable smoke detectors. Now, I'll come back to that idea in a little bit. Before I come back to that, let's talk about binomial distributions. When they say the word binomial, I'm really referring to a family of distributions that help describe data when certain conditions exist. The precursor to this video was one where I talked about random variables, and random variables talk about outcomes of an experiment. You need a thorough understanding of that material before we can talk about distributions like the binomial. I'll put a link in the description if you haven't seen that video or don't understand the concept of random variables. When certain conditions exist for random variables, which I'm going to talk about in a second, the binomial distribution can be used to help us figure out the probability of certain outcomes occurring. This is a good thing, as probabilities get really difficult until we have a distribution like the binomial that's going to make things pretty straightforward. I like to think of working with binomials as a 3-step process. The first step is being able to identify that a binomial distribution actually exists and can be worked with. The second step involves taking the language of what it is you're trying to find and thinking about it in a context that the binomial distribution will be able to use. And then the third step is taking a tool like a probability table or a computer software program and actually using it to find the probabilities that you want. In this video, I'm going to cover the first step. We're going to take a look at how we know when a binomial distribution exists. It's actually quite easy, as there are 4 conditions or criteria that need to be checked to determine whether the binomial distribution is appropriate or not. The first of these conditions is that we've taken a sample from the target population that consists of n identical items or trials. For each of these trials, the second condition says there needs to be 2 and only 2 outcomes. We label them as success and failure. I should note here that success and failure are arbitrary labels, and they don't necessarily talk about something that's inherently good or bad. The binomial likes to think in terms of successes, so we want to make sure we label a success the outcome that we're interested in learning about. The third condition states that the probability of success needs to be p. Because there's only 2 outcomes, the probability of a failure then has to be 1 minus p, or we're going to give that the symbol q. The last criteria is that the trials are independent of one another, meaning that the chance that the first trial is a success has no effect on the second or any of the remaining trials. When these conditions are met, the binomial probability distribution will work. We define a random variable x to be the number of successes in the n trials. We'll then call that random variable x a binomial with values of n and p. Okay, that was a lot. Take a moment, catch your breath, and let me give you an example to help explain how all this stuff fits together. Let's take a look back at the smoke detectors that my firefighter friends were talking about. Suppose they randomly sample 20 homes and take a look at each of the homes to see if there's an operable smoke detector. Is this a binomial? Well, chances are, because you're watching a binomial video, the smart answer is yeah, probably. But why? Well, let's check those 4 conditions. The first one, is there a sample size that we can talk about? Sure, there's n equal 20 homes. The second condition says, for each of those homes, can I define two outcomes? Well, the home either has or does not have an operable smoke detector. We need to label one of those as a success and one of those as a failure. Let's say a home that has an operable smoke detector is a success. According to my friends, 80% of all homes have operable smoke detectors, so we're going to set the value of P equal to 0.8. Therefore, the probability a home doesn't have an operable smoke detector, has to be the other side of that 80%, is 0.2, and that's a symbol we'll give as Q. Can we say the homes are independent? That's a tougher one. If they were randomly sampled, then the chance of the first house having an operable smoke detector probably doesn't affect the next house or the 20th house. And so it's probably a good assumption that the homes will be independent of one another. Therefore, we're going to claim that X, the number of the 20 homes that has an operable smoke detector, will be a binomial random variable with n equal 20 and p equal 0.8. It's going to be important whenever you're working with a binomial to define a value of n and p that you're working with. And that's how we identify binomials. What's the next step? Well, now we want to take a look at some probabilities involved. Suppose my friends want to figure out the probability that more than 15 of the homes will have an operable smoke detector. Well, we know we're going to use the binomial distribution, but the question is, how do we do that? And that, my friends, is a great question that's going to be solved in another video. For now, take a look at some examples of binomials and make sure you can check that each of the 4 conditions is met. Until next time, it's time for you to get to work. So long.